Hey guys! So developed in the 1970s, the American bomber Rockwell B-1 stands out for its impeccable design. This strategic aircraft is still in service and is still impressive in its proportions and flight characteristics. However, this incredibly beautiful and unparalleled aircraft might have never entered serial production. We're going to tell you its story now. Let's mentally transport ourselves to the early 1960s. At that time, the backbone of the U.S. strategic long-range aviation consisted of two types of bombers. The Boeing B-52 Stratofortress, which entered service in 1955, and the Convair B-58 Hustler, which appeared in 1960. The fate of these two aircraft was different. The breakthrough, technologically advanced B-58 was capable of a maximum speed of Mach 2 and was retired as early as 1970 due to flight and technical characteristics that didn't satisfy the military, as well as the high cost of the project. During its 10 years of service, the B-58 never participated in combat operations. In contrast, the career of the B-52 turned out to be much more successful. Few people could have predicted at the time that this 8-engine subsonic bomber would still be in service in the 21st century. Moreover, they plan to use it until the 2040s, when the last aircraft will reach the end of their operational life. However, no one thought about this in the 1960s. Aviation was advancing by leaps and bounds, and the military set out increasingly high requirements for new aircraft. With Richard Nixon coming to power in 1969, the AMSA, Advanced Manned Strategic Aircraft Program, gained new momentum. The newly inaugurated President of the United States and his team advocated for the creation of a new universal long-range bomber to replace the B-52. Consequently, the U.S. Air Force announced the design contest for the new aircraft, which was officially designated as the B-1 program. The winner was declared by the mid-70s. It was the aerospace company North American Rockwell, which later changed its name to Rockwell International. According to the contract terms, they were to build one prototype for ground static testing and 3 for flight testing. After the completion of the test program, the U.S. Air Force was supposed to receive 240 serial production B-1 bombers. Flight testing began in December 1974, when the prototype B-1, measuring 44.8 meters in length with a wingspan of 44 meters, made its maiden flight. Now, let's delve deeper into the design features of the Rockwell B-1 Lancer bomber. The aircraft was designed according to a normal aerodynamic scheme with a variable sweep wing. It had a blended wing body configuration where the wings smoothly merged with the fuselage. This solution had two main advantages. The lifting body provided a substantial increase in lift, while the additional volume inside the airframe could be used to accommodate additional equipment. The airframe was made with extensive use of titanium alloys, accounting for approximately 20% of its weight. Titanium alloys were used in nodes subjected to particularly high loads. For example, the crossbeam of the center wing and parts of the wing sweep mechanism were made from materials containing this exceptionally strong metal. In addition to titanium alloys, the airframe also used aluminum alloys, making up about 40% of its mass, as well as steel, fiberglass, and a very small fraction of composite materials. The B-1 was equipped with a variable sweep wing to enhance takeoff and landing characteristics and maneuverability at subsonic speeds. During takeoff and landing, the wing's leading edge sweep angle was 15 degrees. For supersonic cruising at high altitudes, it was 25 degrees. And for high-speed flights at high or low altitudes, the sweep angle varied from 50 to the maximum value of 67.5 degrees. The tail assembly consisted of a single keel equipped with a rudder and a mid-mounted, fully movable stabilizer. To ensure more stable and smoother flight at low altitudes in conditions of strong turbulence, engineers developed a special vibration damping system. Sensors distributed throughout the fuselage tracked changes in aerodynamic load. Signals from these sensors were sent to the onboard computer, which then automatically deflected the rudder and special aerodynamic surfaces located in the nose section. This technical solution significantly extended the airframe's service life and slightly reduced vibration. The power plant of the B-1 comprised 4 General Electric F101 GE100 turbojet engines, each capable of producing a maximum afterburner takeoff thrust of 13.5 tons. The engines were arranged in pairs with 2 nacelles, which were positioned at a certain distance from each other. Adjustable air intakes were utilized to optimize operations at high supersonic speeds. The aircraft was designed to reach speeds of Mach 2 at high altitudes and Mach 0.8 at altitudes between 150 and 300 meters. The crew of the aircraft consisted of 4 individuals, 2 pilots seated side by side in the front, and 2 weapons and defense systems operators seated at the rear. The crew compartment served also as a detachable escape capsule, enabling aircraft egress during all flight modes and while on the ground. The weapons were placed in 3 internal cargo compartments and on 4 pylons beneath the fuselage. The primary armament consisted of AGM-69 SRAM cruise missiles with a nuclear warhead. Each internal component could accommodate up to 8 of these missiles, mounted on a specialized rotating launcher. In addition to this type of weapon, it was planned to use conventional or nuclear free-falling bombs. After the first flight, testing under the B-1 program continued as planned. Within 6 months, the first prototype reached the speed of sound, and a year later, the second B-1 test aircraft reached a speed of 2,717 kilometers per hour. The third aircraft was used to test the onboard electronic equipment. This part of the testing turned out to be the most complex, as no military aircraft had ever had such sophisticated electronics in such quantities. By the end of 1976, representatives of the Ministry of Defense stated that nearly everything was ready for the serial production of the new bomber. In the same year, an additional 4th flight prototype was ordered for further development of the program. It was intended to serve as a prototype for serial production models. Everything seemed to be going according to plan, but in the summer of 1977, President Jimmy Carter announced the complete termination of the B-1 program. It is hard to say that it was a completely unexpected decision. The reasons for shutting down the program lay across several facets: politics, economics, and military doctrine. Even during his election campaign, Carter had announced his support for discontinuing the B-1 program. The main justification for the voters was its cost. In 6 years since the program started in 1971, the estimated cost of one serial aircraft had nearly doubled. All other reasons were related to rational combat use and the emergence of new technologies. The AGM-86 ALCM was expected to replace the AGM-69 SRAM. Work on the AGM-86 ALCM was conducted concurrently with the B-1. The AGM-86 ALCM was projected to have a launch range of up to 1,200 kilometers, compared to a modest 170 kilometers for the AGM-69. The Carter administration logically calculated that re-equipping the B-52 with new cruise missiles would be much cheaper than creating a new aircraft platform for them. The necessity for low-altitude penetration of enemy air defenses was no longer considered viable. Besides new cruise missiles, the military's minds were captivated by the concept of low-radar visibility aircraft. During Carter's presidency, 2 top-secret military programs were launched, leading to the creation of the tactical stealth aircraft Lockheed F-117 and the long-range strategic bomber Northrop B-2. The latter remains in service to this day. Despite formal ending of government support, flight testing of the B-1 continued for several research programs under the Department of Defense's backing. These tests involved the launch of cruise missiles and further development of the onboard electronic equipment. The B-1 project received a new lease of life in the early 80s when the Department of Defense announced a contest designated as LRSA. Essentially, the requirements for this program were similar to those for the creation of the B-1. The objective was overcoming enemy air defenses using cruise missiles and free-falling bombs equipped with nuclear warheads, as well as utilizing conventional non-nuclear weapons. The B-1 was competing against projects by Boeing, proposing to convert the passenger 747 into a carrier for cruise missiles, and the upgraded version of the General Dynamics F-111 tactical bomber. Given that Rockwell's aircraft fully met all the requirements and had already undergone an extensive testing program, the winner of the contest was essentially known in advance. In October 1981, President Reagan announced that the Department of Defense would order 100 bombers from Rockwell. The new aircraft was planned as a transitional model from the aging B-52 to the new stealthy B-2 bomber, which was being developed by Northrop and scheduled to enter service in the mid-90s. Few could have foreseen at the time that 37 years later, all three types of these bombers would still be in service. The aircraft was completely optimized for its primary profile, flying at low altitudes at high subsonic speeds. Changes were made to the design of the air intakes, which became fixed, increasing the maximum speed at ground level to Mach 0.92. However, the supersonic speed at higher altitudes had to be sacrificed and could no longer exceed Mach 1.25. To extend the flight range, the maximum takeoff weight was increased to 216 tons. Additional fuel tanks could be accommodated in the bomb bay. Designers had to reinforce the airframe, increasing the empty weight of the aircraft by several tons. The B-1B was equipped with technology to reduce radar visibility. For example, the air intake ducts had an S-shaped form to shield the compressor blades. The serial B-1B received an upgraded version of the General Electric F-101 GE-102 dual-spool turbofan jet engines, which had increased takeoff thrust. Significant changes were also introduced to the onboard equipment. The B-1B was equipped with the AN/APG-164 multi-mode radar station, featuring a passive electronically scanned array. This RLS was used for tasks such as mapping, automatic terrain following, and detecting and tracking ground targets. The core of the aircraft's defense complex was the ALQ-161 electronic warfare system. It included equipment for radio reconnaissance, jamming across a wide frequency range, and a rear attack warning block. To create passive jamming, containers with dipole reflectors and thermal traps were also used. The bomber was armed with free-falling nuclear bombs B-61 and B-83. Up to 24 units of these types could be accommodated on 3 rotary launchers. An alternative armament option was the short-ranged AGM-69 SRAM cruise missiles. By the 1990s, the political and military situation had changed significantly. The B-1B, designed for nuclear strikes, was effectively no longer needed. According to the terms of the Agreement on Reduction and Limitation of Strategic Offensive Arms between the USA and Russia in 1995, the aircraft officially ceased to be a nuclear weapons carrier. Several years before that, a program was initiated to upgrade the B-1B to enable the use of conventional weapons. The B-1B could carry up to 34 tons of weaponry in 3 bomb bays. The aircraft could also carry an additional 27.6 tons on 6 external hardpoints, but these mounts were removed due to international agreements on limiting strategic armaments. Each bomb bay could hold 8 units of nuclear weapons in a rotary launcher. The range of weaponry now included free-falling bombs of 250 and 900 kilograms, as well as sea mines. In the early 2000s, guided precision bombs, JDAM, were added to this list. The B-1B's first combat experience occurred during Operation Desert Fox in early 1998, when U.S. and British coalition forces conducted strikes on Iraq. Since then, the aircraft have been used in all military operations conducted by the United States. No losses from enemy fire have officially been recorded. Throughout its lifespan, the B-1B Lancer project was consistently subject to severe criticism. In the late 1980s, when the serial aircraft was just entering service, doubts were raised by the U.S. military about the possibility of penetrating the air defenses of the Soviet Union. There was consideration of using the B-1B as a long-range cruise missile carrier without entering the enemy's air defense zone. Eventually, the bomber became a platform for using non-nuclear strike means, employing the same arsenal as tactical aviation. Well, that's all for today, friends. Like the video if you found it interesting, share your thoughts in the comments, and we'll see you next time.